Hey everyone, we're here in the wood shop because today we're going to run some materials tests. We're going to take some wooden specimens and pull them apart in tension until they fail. Let's take a closer look and see what we can learn from this experiment. As you can see here, Josh is using the table saw to cut a single piece of wood to make our material testing specimens. All of the specimens were produced to have the same shape, size, and cross-section. As you can see, the middle portion of the specimen has purposefully been made smaller than the ends, so that the material failure will be more likely to occur in this middle region than where the specimen is being held at either ends in the grips. Remember that this makes these dog bone specimens. After collecting our initial measurements, Josh loads the material testing specimens into the loading machine and tightens the grips nice and tight. Now that the specimen has been secured, the testing parameters can be programmed into the computer software and we can begin the test to pull the specimens apart. When you're running materials tests like the one we're running right now, you always want to make sure that you're wearing the proper safety equipment, which in this case is safety glasses. You do this so that you're safe, because the materials you're testing can sometimes fail quite suddenly and with devastating consequences. Oh my God! That means a catastrophic failure is imminent! Get out of the way! Just kidding. There's no need to worry, I am totally fine. There was not actually an explosion in the wood shop. When you're testing material specimens, they don't usually explode like that. The failure is actually a lot less exciting. When you test wood or concrete or even small samples of metal, you might expect there to be a loud boom or explosion, but there aren't really any big fireworks. Usually the material fails in a little click or snap. You almost sometimes don't even notice it. Let's take a closer look at how the materials failed that we just tested. As you can see here, the materials failed when the wooden fibers inside were pulled apart, and each sample held between 1,500 to 2,500 pounds before failure. What is interesting to take note of is that some specimens seem to fail differently than others. If we look more closely at specimen 1, you'll notice that the sample split right down the middle at its maximum load. Whereas if we take a closer look at specimen 6 on the end, it seemed to fail in the grips, where the wood split apart. Well, there you have it. We just ran some material tests. We took 6 specimens of wood. They were all cut from the same block. They all had the same shape, size, cross-section. They were all essentially exactly the same. Yet, we achieved different results for all of them, and they all failed in different ways. What does this mean? And what lessons can we learn from this test? As a student, you'll also have the opportunity to use the material testing machines. Jacob Garnett, a senior engineering student at UMD, is testing 3D printed specimens along with his partner James Shen for the ENES 472 Additive Manufacturing and Materials course at UMD. Together, they are studying the effects of print orientation on the strength of 3D printed parts. They plan to print 105 material samples using 3 different types of materials across 7 different angles, which you can see here are varied in 15-degree increments from 0 to 90 degrees. After testing each specimen, they look more closely under the microscope to see what they can learn from their tests, and learn how the materials failed. Hopefully, they believe that this information will be useful to all sorts of different engineers.